Day 7 of trying to go from jacked to genius by teaching you guys shit I've learned in my university program. So you guys really seem to like the integrals, and what better way to keep it going than compute another integral? How would you guys solve the integral e to the x times sine of x? So right away, we recognize that we have a product here. It's e to the x being multiplied by sine of x. We know of two methods to compute this integral. We have u sub and we have integration by parts. Now to figure out if you can use u sub, we're gonna look at our integral here and we'll take the derivative of one of the functions. We'll take the derivative of e to the x. It's going to give us e to the x. And we see that e to the x is not going to cancel out sine of x. See that the derivative of sine of x is not going to cancel out e to the x. So u substitution is clearly not an option here. So we're left with integration by parts. We know that the formula for integration by parts is uv minus the integral of v du. To set our parameters now, we'll set u is equal to e to the x. Generally, you want to set u is equal to a polynomial. Cosine x, sine x is also really good, but if you have e to the x, that's basically always going to be your u. And the derivative of u is just equal to e to the x times d of x. Now we have to find what our d of v is. D of v is equal to everything except u. Be sine of x times d of x. And then v is just the integral of this. V is equal to the integral of d of v, which is negative cosine of x. Now we can head back down and plug in our known parameters. U is equal to e to the x, v is equal to negative cosine of x, minus v is equal to negative cosine of x, and du is equal to e to the x times dx. Now we can take this negative out and we can also move this negative to the front. So I'll do that just to make it look better. We can also move our e to the x to the front. It's going to make it look nicer. So we have negative e to the x times cosine of x plus the integral of e to the x times cosine of x times d of x. Now we have to compute the integral of this. And once again, we can't use u sub because the derivative of e to the x is not going to cancel out that, and the derivative of cosine not going to cancel out that. So it looks like we have to do integration by parts again. And to do that, we'll set our variables. We're going to have to set u is equal to e to the x and d of u is equal to e to the x times d of x. Then we'll set d of v. D of v is just, remember, it's everything except u. So it would be cosine x times d of x. And then v is just the integral of d of v, integral of cosine sine of x. Now we have all of our known parameters to do integration by parts again. So we're going to head down here and just plug it into our integral. We already know the formula, so we'll just rewrite it as is. It would be negative e to the x times cosine of x. We'll compute this integral. We'll just plug it in directly. uv, which would be e to the x, is our u. Our v is sine of x minus our integral v du. So it would be v then du, which is equal to sine of x times e to the x dx. Computed in our integration by parts for a second time, and it looks like if we continue on this way, we're just going to be doing integration by parts for the rest of our lives. So let's take a look at this integral here. This looks very similar to our starting integral. When you reach that state, you have to recognize this integral looks exactly like this integral here, and you have to move it to the left-hand side. So we would combine our like terms by moving this over to the left-hand side. And remember, on the left-hand side, we have e to the x times sine of x times d to the x. So these are the exact same. So we'll move it over to the left-hand side, which gives us 2e to the x times sine of x d to the x, with negative e to the x times cosine of x plus e sine of x. Now it's just a matter of isolating this. Well, how do you isolate it? You just divide it by 2. And it's going to give us our final integral, negative e to the x cosine of x plus e to the x sine of x. And we have to divide it by 2 is equal to our integral e to the x times sine of x times d of x. That's how you would compute the integral of e to the x times sine of x.